This is Kamal Sarma. Welcome back to my class. Today I am going to discuss about the bending moment and shear force diagram with a different kind of loading. So today I'll be discussing the bending moment and shear force diagram for a special kind of condition, special kind of loading. Say if you have a simply supported beam like this, which is pin supported on one end, the roller supported on the other end, and which is subjected at the middle, say a moment. This moment, if you give a numerical value, say consider it is 100 kilonewton meter or 100 kip feet. They are not same because one 10 kilonewton equal to 2.25 kip. This is the relation. And also, yes, I assume the distance from here to here, the span length is 10 either meter or feet from there. This is the span. Meter is used in SI system and feet is used in American system. So now, but they're also not same. 1 meter equal to 3 feet, 3.4 inches. This is the relation. But I am keeping the numerical value same for convenience of calculation. Now, when this type of how this type of things may happen, a concentrated load, no shear, no force. Suppose you have a shaft there. The mechanical people know it better. So somewhere there is a torque on this. So that will cause the same moment of 100 kilonewton meter or 100 kip feet. Now, how to draw the bending moment diagram and shear force diagram for a condition like this? This is a tricky question, and many times I saw it is coming in the exam. So what happens? So when a moment is there, you see, when a support like this cannot resist it directly, you cannot resist it because these two supports cannot take any moment. That takes only vertical or horizontal forces. This end and this end only the vertical. But had it been a cantilever like this, cantilever, that means this end is fixed. If you have a moment like that, say M, the reaction would have been also the same thing, M, the counter, the balancing, action equal to reaction. Okay, this is how it is. So here we cannot do that. Here only the vertical forces or horizontal forces. This end is only vertical. So what happens? They will develop a force like this. This will be downward and this will be upward. Just like this. You are bending this beam like this and there will be forces at the end. Try to balance it. Opposite direction. This end will be pulling down. This will be pushing up. So what is the value? They are forming a torque. They are forming a couple. Okay? Two forces at a distance, equal amount. That's the important. The equal forces at a distance try to balance it. So what is this value? 100 divided by 10 equal to 10. This is also 10. So 10 times 10 is 100. So this will balance this moment. So you have a force, downward force there, upward force there. How to draw the bending moment and shear force diagram? Look here. So here we have 10, here upward 10. Okay? Now draw the bending moment and shear force diagram. So we have a convention of shear force like this, right? If you consider from left to right, this is positive, this is negative. If you consider from that way, so it is upward negative, downward positive. So take that convention. So now from here to here, there is no particle force, there is shear force, no shear force no force coming in other than two reactions. So if you draw this one at this point, shear force will be like this, downward is negative. So we have 10. From here to here, there is no force. This 10 will continue all the way there, same value. At this point, it's upward 10. Upward 10 is positive, downward is negative. So it will balance, 10 will balance with the 10. So this is a negative shear force diagram. And value is 10. 10 kilonewton or 10 kip, either way. But all, this is also 10 kilonewton or 10 kip. This is the shear force diagram. What is the bending moment diagram? Bending moment diagram, we have a sign convention like this. That means sagging is positive, hogging is negative. So what happens? This will be acting on this end. What will happen? It will try to pull the beam down like this. So it is this condition, negative. So it is downward, causing a moment like this. So like this, see this? If you have a beam, try to bend it like this. It is bending like this. So this is the hogging moment. So this will be your negative. Take the moment here. It is 5. It's a midpoint. This is 5. So 10 times 5 is 50, but it is negative. It is causing a anti-clockwise moment. So it is negative 5 going down like this. So at this point, this is constant. The bending moment is linear. We know that. At this point, 100 kilonewton meter or kip feet is coming. This is a clockwise moment. Clockwise moment we assumed on this from here. We are going from left to right. Clockwise is positive. So it will at this point, as soon as it reaches this point, just right of this, your 100 will come up. So this is 50. 10 times 5 is 50. So another, this will go up, taking it to the positive side. So you have from here to here it is 50. So from this point to here it is, from here to here it is 100. From this point to this is 50. So it is neutralizing 50, then going up by 50. So total 100. So there is no force in between, no moment, because moment at this point will be 0. So it will also have a linear shape like that. This is positive, this is negative. If you take it from right to left, it is positive. 10 times 5, 50. This is causing an anti-clockwise. going down, 50, 50, 100, by that is 50 positive, 50 negative going down, then rest is coming up. This is the bending moment diagram. Shear force diagram is all negative, bending moment is partially negative, partially positive for your moment. So in civil engineering, how will you have a condition like this? Similarly, suppose let us assume this time the span is from here to here, here to here, 20. I am increasing the value because I need to have a bracket there at the top. So here at the midpoint, there's a connection like that, and the bracket there, which is 5 feet, or from here to here the distance is 5. And from here to here it is 10. From here it is 10. And at this end, at the end, there is a load. This is a 20 kilonewton or 20 kip. This is 10 meter or 10 feet. This is 10 meter or 10 feet, and total length is, the span is from here to here 20. So this length is here to here is 5. This may happen in civil engineering construction. You have a beam, there is a bracket connection there, then there's another member is coming there. At the end of the member, there is a 20 kilonewton or 20 kip feet is applied, concentrated load. This may happen. So what happens? This is a bracket connection. What this will do? This load can be the bracketed load. It is not acting here at the beam, but acting somewhere there. There is no connection, right? There is no connection from this bracket here to there. So you cannot apply the force directly here. But it is causing a moment there. 20 times 5 is 100. That moment will be transferred to here. But how the moment will be applied? So when you have a force like this, we can simplify it. We give another force 20 there and another force here 20 there. So 20, this one considered load 20, another 20. For simplify our work, 20 and 20. These two, 20 minus 20 is 0. So this is the same as the earlier case. This 20 and 20 has no meaning. They are acting against each other, balancing each other. But this 20 will remain there. But look here very carefully. This 20 and this 20, they will form a couple. So that means we have a moment. So that moment is, what is the value of the moment? 20 times 5, this is the distance is 5, 100. This moment value is 100. Form a couple by this reaction. So clockwise moment of 20 kilonewton meter or kip feet. It is 100. 20 times 5 is 100. 20 times 5 is 100 kilonewton, and these two will form a couple like that, and this will remain unbalanced. now. So that means you have a case like this. If you redraw it, this loading if you redraw the moment or the forces, this 20 and this 20 upward, they form a moment that is your 100 kilonewton meter or cube feet. Plus the unbalanced force is 20. Kilonewton or cube, because these two force actually what I did, this 20 kilonewton cube at the end of the bracket, I put additional forces here 20, here 20, this 20 and that 20 is forming a couple, a moment that is equal to 100, 20 times 5, and the remaining unbalanced force is 20 going downward here. Simplified the moment. So you have a combination of particle force and moment because of this bracket connection. So what will be the shear force diagram? Shear force diagram, what is the, first of all, in a shear force diagram, always you have to find the reaction. What is the reactions? First of all, for this 20 at the middle, you have a vertical force of 10 there and 10 there, equally distributed. That means 10 goes there, 10 goes there, it's symmetric. What about 100? Clockwise. For the 100 going this way, so there will be a moment like that, like the earlier problem. It will be like this. So this is going down, this is going up. What is the value? 100 divided by, this length is 20, 100 divided by 20 is 5. This is 5. So this is negative, this is positive, this is positive, this is positive because we are considering upward positive. So total value is 10 plus minus 5. This is minus, pulling down, minus 5 equal to 5. Total reaction. This side 10 plus 5, both are same direction, so it is 15. So reactions are 5 and 15, not equal. Now, let us draw the bending shear force diagram. Shear force diagram will be, this 5 will be considered upward, right? So what will happen? A constant upward, there is no force here, so it will be 5 there. Nothing there, no force in between. This 5 will continue as a constant value until this point. At this point, suddenly the 20 comes in. Particle force. Forget about the moment. You do not have to worry about the moment when you draw the shear force diagram. That constant moment, don't take care of it, don't forget it. The only 20 keep is coming down for shear force, the 20 coming down and putting like this. It is going downward, negative. So this is 5, so 20 minus 5 is 15. So on the negative side, it is 15. Okay? Then from to here, no force here to here, nothing, no UDL, nothing else. Had there been a UDL, suppose this has got a UDL force, you have to take that into account. Understand? So if there is a UDL, additional UDL force is there, in drawing the shear force diagram, you have to consider that also. Or if there is a trapezoidal load, you have to consider that also. But it is a very simple case. So you do not have to take care of the UDL. Had there been UDL like that, our shear force diagram would have been something like going down linearly. But we do not have anything, so it is constant. No load in between. Now, from here to here, this 15 will continue upward here. This 15 will go and balance out. This is positive shear force and this is negative shear force diagram. So this is the shear force diagram. This is SF diagram. Okay. Now, what is the moment diagram? I have to erase this. I do not have a bigger board, so I have to erase this. But you remember what you know what I am doing. This is the vertically upward. Upward is positive. There is no force in between. It remains constant. Then 20 comes in, pushing it down because downward is negative. So balance is 15 on this side. There is no force in between. It's continue like that. Then 15 comes up and ultimately it is on the baseline, is 0. This is the graphical representation of shear force diagram. Again, I told you, if you had a UDL like this, suppose you have additional UDL is there. So your bending moment and shear force diagram would have been like this. Coming like this, and from here it will be further down. But this is not the case now because we do not have force in between. There is no UDL. There is no UDL. But in your case, in exam hall, don't be afraid. If you have a UDL, consider that an additional force to find out the reactions for the UDL also. Because every time you have a force on a beam, whatever it is, vertical force, I mean, any inclined force, horizontal component will be taken care at the support. The horizontal force has no effect on shear force diagram or bending moment. Only the vertical force or the concentrated moment. Now, this is the case. In this particular case, we have concentrated load there going down and like this, all constant. 15 and this is side 15, this is 15, this is shear force diagram. Let us draw the bending moment diagram. So bending moment diagram, from here to here, this is 5 kilonewton or 5 kip. This is 15 kilonewton. Or 15 kip. So now, what is the moment here? No force is there, right? 5 times of 10. From here to here, distance is 10. Okay? This is from here to here, it is 10. This is 10. So this is 5, this is 15. So 5 times of 10 equal to 50. So if you draw the bending moment diagram like this, from here there is no force, no load. This is the only moment, only force on this side. You know the shear force is constant here, so we have a bending moment like this, linear. This value is 50. Here at this point. This is positive because it is clockwise. So it is positive. But what happens here? Suddenly additional 100 comes in at one point, concentrated. So this is also clockwise. It will add up. So you add up 10 to this. Add up 100 to this. So it will be from here to here is 100 plus 50, it is 150. then there is no moment, the moment will be 0 at this point. It is a simple support. So it is going linear. This is linear, straight line. So it is positive, all positive. 50 from here to here, 150 from here to here. Let us take from right to left. This is also hogging. It's positive. So 15 times 10, from here to here distance is 10. 15 times 10 is 150. 150. Then 100, it is causing a moment like this, negative moment, hogging, coming down 100. Then rest is 50, balance 50. How can you get it? This time you take from right, from left, 5 times of 150. Both way it is the same value, same. So if you do not get the same value calculating from left or right, then you made a mistake. Be careful on that. You screwed up somewhere. Okay? So when it doesn't make it, then you know there is something wrong. So now I am special case for these two. All these two cases I consider. This is your bending moment diagram. All positive. Somebody might be considering if somewhere here, if the load is not at the middle, it is load middle means is you get 50, it is 10 goes there, 10 goes there for this 20 kilonewton and 100 is at this value. What will happen if the load, your moment is, or bracket is somewhere here? Suppose instead of bracket here, we have the bracket connection here. This is 5. This is your 5. This is again 5. This is 10. What will happen if you have a case like this? This is a special case or similar case, but now look here, 20, no force is there. So what we'll do, we balance this 20 by having another force 20 upward, 20 downward at this point. Actually it is meaningless. If you have 20 upward, 20 downward, both cancels each other. So only it is the previous case. But now we are having additional force we are applying this way so that we can convert it to a moment and a force. So this 20 and this 20 will form a couple. So this will be like this. Twenty times 5 is at this point at 1/4. This value is 100 kilonewton or meter or kip per feet, and a constant load there 20, either kilonewton or kip, same thing, number is same, units I am considered different unit. So what is this will do? I told you one time, instead of taking the moment and find out all the rigorous steps, the 20 will be divided From here to here is 15 and here it is 5, right? So it will be divided with a ratio. So it is closer to this support. So more reaction will be here. Less reaction will be there. The ratio will be vertically upward force here 20 times the other side span 15 divided by 20 total span. 20 is the load, 15 is the other span, not the closer span, the opposite to the other side. So 15 divided by 20 from here to here. So this is 15. So if it is there, it is 15 coming there. Similarly, 20 minus 15, this will be 5. This is 5 kilonewton or 5 kip, and this is 15 kilonewton or 15 kip. Okay? Now, this is 100 kilonewton, but it is causing a moment like this, right? This moment will be, it is not that it will be more reaction there, more reaction there. No. This reaction remains the same because they will form a couple to counter this. So, if you have a moment like this force will be downward. For the moment, this force will be upward. What is the value? Value is the same, 100 divided by 20. Here also 100 divided by 20. Because the reaction should be equal to form a couple. So 100 divided by 20 is 5. Downward. This is 100 divided by 25 upward. Okay. So together, what will happen? 15 upward, 5 downward. Okay. So this will be 15 minus 5 is 10. So 10 upward. Kilonewton or kip. This 5 is going up, this 5 is also going up. Together they will make it 10. 10 kip kilonewton or 10 kip. Okay. So now 5 is 5 plus 5. 15 minus 5 is 10 and 5 plus 5 10. So rest of the things are simple. So this is shear force is what? Shear force will be 5 is going up, this is 10, that is 10. You get baseline here. So from here to here 10. Okay. Then 20 comes in, balance out 10th. Then this from here to here 10. This is 10, this is 10, this is negative, this is negative, this is positive. This is the shear force diagram. When you find the reactions of the bracket, the moment, whatever moment you get, it will affect equal effect on both the support. But the force has got a different effect because it is closer to this. Higher percentage will be here, lesser percentage is there, and the percentage I calculated by the ratio of the distance. This is very simple. Now, what is the moment? Moment is just something like this, same way. 10 times 5, this is causing a clockwise moment. So 10 times 5, 50. Then 100 comes in, they are clockwise again, positive. So 100 comes in there. So it becomes from here to here 150. 10 plus 50, 50, and no nothing there, it goes like that, 0 there, it is positive, all positive, bending moment. Now if you consider from right to left, so it is positive, sagging moment. It will bend like this, anti-clockwise movement. So 10 times 15, 150 from here to here. Then 100 comes in, it is negative moment coming in. So it is reducing the value by 100, remaining 50. Then join these two ends, it is 50. So this is a case similar to that, but I am showing the difference. What happens if it is not at the middle, it is somewhere else. So same is the case. If there is no force like the earlier case, this is similar is the case. If you have remembered the first problem, we have if you have a moment at the mid somewhere, is the M, the reactions will be not same reaction. It will cause them couple and the same value, M over, if its length is L, M over L, here also M over L, and same amount of reactions and shear force. You can draw the shear force diagram like this, and moment will be similar. You look at that, you can practice at home, you will see the similar type of figure, but only the distance from the left hand will be different. So this is all for today. I hope you understand. This is a special case, special loading case for a beam with concentrated load or with concentrated moment, not load. Then what, or with a bracketed load. So how can you deal with this type of problem? So this is all for today. I hope you enjoyed the class and learned something. So next time we will be talking about most likely trapezoidal load or triangular load, and that comes in the building due to load from slabs. So this is all for today. Thank you very much. Appreciate it. Have a good day. Bye.